So, all right, guys. So, close. Yeah, I'm through this guy. I'm through. Great. I'm through. Now, that was multi-stage. Now, the next on our agenda is Docker volume. Docker volume, as the name is, volumes in Docker are used to persist data. When you hear about data persistency, right, keeping your data alive, all right, you can set that up in Docker. So all the while, we have been creating containers. We've been creating containers, and we don't know where our container is going. All the data, right, from our container are going. So it means that if we delete the container, we're also going to lose the data that were created by these containers, right? They're created by this container, you know? So for we to avoid data loss, we use the concept. Docker came up with the concept of what? Persisting the data, right? Thereby, you can never lose a container's data. So the idea is just to persist the data, Docker volumes, right? Volumes in Docker are used to persist data. Boom, just close. Now, there are different kinds of volume, Docker volumes. We have the binding volume. Types of Docker volumes. Now, we have what we call binding volume. We have normal volume. Then we have anonymous volume. There's a binding volume, a binding volume, a normal volume, and an anonymous volume. So let's define these volumes and see how to implement them one after the other. A binding volume a binding volume is a volume type thereby a created directory, a created directory okay, thereby a directory, thereby a directory created on the host VM, the host virtual machine is mapped to a directory, a data, a data directory within the container. I'll explain. Now, a binding volume is a volume type there whereby a directory created on the host machine. Okay. Binding volume is a volume type in which I would say whereby, comma, a directory, or call it folder, all right, created on the host virtual machine is mapped to a data directory within the container. Let me explain. Now look at this now. In here now, I want to create a directory. Let me say mkdir, my data, my DB files. See, my DB files. Now look at now. My DB files is empty, right? Great. So now I want to map this directory to a data directory within a container. Such a process is known as binding volume. Such a process is known as what? Binding volume. Now let's take, for instance, MySQL. Now I want to create MySQL container. You know, MySQL is a database, and MySQL has MySQL home, where all the files relating to MySQL is being saved. See, all right, let me leave MySQL for now. Let me take a simple CentOS. Let me create a container. Guys, just watch. Docker run dash dit. All right. The name is CentCon. From image, CentOS. So I'm creating a CentOS container. Guys, watch you. All right. So if I do Docker PS, this container is running, CentCon. Now let me execute into this container. So if I say Docker exec dash it CentCon bash, I am now inside of this container, right? Great. See you. Okay, let me not use this method. Let me use the Docker file. Let me create an image out of it. Let me exit. Let me delete this container. CentCon dash F is gone. Let me use the Docker file. All right. Let me say vim CentOS df. All right. Now from CentOS, that's latest. What I need is work dir is /app. All right. Then what I need to keep this image alive. So I'll say cmd I'll say -f dev -null. All right. So I need to run this thing in the foreground. Okay, let me see. Just give this guy alive. Now let me create an image, docker build -t sent img from Docker file CentOS. Created Docker images. I have where is it? Sent img. Now let me create a container out of this guy. So I'll say what docker run -d. The name is sent_con. From which image? Sent img. All right, created. Let's see if it's alive. Oh, it's not alive. It's not alive. So what can we do? How to create a process. How to create a process in CentOS Docker image. Okay, from Docker file. How to start a process within the let me check this. I need to create a process. CentOS. Or let me use a Docker. Let me use the official Docker CentOS. All right, the official image. Then I should see a Docker file somewhere. So let's look for Docker file. Docker file should be at the bottom. Docker file. Okay, so they've used this guy to create a process. Oh no, this is from systemd. Enable app user sbin init. Yeah, CentOS now. What's this? All right, so this is what they did. User sbin init. So this guy will create a running process inside of this CentOS image. So this is what I will do. I am going to user sbin init just to keep this image alive. All right, CentOS. So I'll say user sbin init. All right, slash. All right, slash user sbin init. Great. So let's rebuild. So Docker build has been built. Now let's Docker rm sent_con. Let's rerun it. Rerun. Created. Now Docker ps. So you can see we've been able to create a process, right, in a running image so that the image does not exit because it is an OS. OS doesn't have a process, so you have to manually create it. Now that we have this guy now, so let's exec. So Docker exec it sent_con bash. You can see now I am inside of what? The container, and the place I'm going to save all my data is /app. So you can see this /app is empty. Let's see. /app is absolutely empty. I want to create some files here. Touch finance 1 to 3.csv. Take note, guys. So this guy is going to create for me files from finance 1, 2, and 3 with the extension .csv. So I've created 3 files. So this is my data location within my container. I'm assuming this is where I store my important files. All right. And cat audit.csv. This is for auditing. So I'm assuming that this is important file. This is my important directory. Okay, great. If I exit, if I delete this container, docker rm -f sent_con, right? Sent con. This container has been deleted. And obviously, I'm going to lose this data. I've lost those data. Now let's try to recreate the container. Let me try to exec. Now let me check this location. If I still have those data. I have lost the data. The data has not been persisted. So that is why Docker, they came up, they said, no, we need to save our data. Even if the container dies, our data will still be alive. Now let's check how to create a persisting data. Persisting data. Now, I'm going to exit. All right. I'm going to kill this container. I'm going to delete it. Delete. I'm going to recreate this container. But now, with a different option, I'll say -v. Because what? I want to persist my data. Now, in my host machine here, I have a directory called what? My DB files. So I want to map my created directory towards a directory within what? Within the container. So I'll say docker run, the name -d, the name of the container, -v. All right. So -v is used for creating what? Volume. -v, the created directory, column, the directory within the container. So it means that I'm going to map anything that happens here, /app, inside of the container into what? Into my DB files outside of the container. I'll hit enter. This guy has been created, Docker PS. Now let's exec into this container. Exec, I'm inside. Do we have anything here? None. Let's create some files. Now let me exit before I create some files. Now let's check. Do we have anything under my DB files? No. Let's go back. Exec. Now touch finance to 4.csv. .csv. Enter. I have these files. All right. Cat audit.csv. This is an important auditing. Take note. Save. Or this is not a draw. I need to delete some of these images. So let's check auditing. We have it. I will exit from the container. Guys, just wait. Let me delete some of these images. My system is now drawing. So I'm going to Docker RMI. So I'll remove based on the ID. That guy. Open JDK. That guy. Who else? Multi-stage. That guy. All right. So Docker images. Docker image run. Remove all those dangling images. Yes, they are done. So Docker images. This guy is still there. No other. Now, let's check this directory. My DB. Whoa, 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 whoa. No, no, no. Why? my DB files. Wait, it was persisted now. I persisted data. Wait, history. CentCon, why? Slash app. Wait, why? Volume my DB files. Column. Wait, let me touch some file. Touch new file. Exit. Oh, sorry. I don't go exit completely. Now let's change directory multi. Now let's docker exec it centcon bash. Okay, wait. It's us. Wait, go back into again. pwd slash app now. Exit. mkdir me. Docker run. Wait, $pwd slash me. Docker. I dey come. Why this thing do like this? CentCons. Docker exec. CentCons. touch.txt. Okay, guys. I'm seeing what happened. Let me explain. Docker ps. Let me remove these two containers. Docker rm -f CentCons. Now let me show us what happened. All right. So let me remove even this directory. So we have left with, all right, let me remove the file inside of this guy. My DB new file. So it's empty, right? Great. So I'm supposed to specify the full path, pwd. So the full path is this path, right? And that path is represented with an environment variable called, because pwd is an environment variable. So if I say echo $pwd, it's going to respond this guy, right? It's going to output my current present working directory, right? So because this guy is a variable. It's a global variable that defines present working directory. Okay. So now for that, so if I need to target this, my guy, my files, so I will do something like this. I'll say Docker build, sorry, Docker run pwd my, sorry, $pwd slash my waiting db files column app. So with this, I should be able to target everything. Fine. Now, CO, let's now do a Docker exec into that container. Sendcon bash. I'm inside. It's empty. Now touch some files. Touch finance 1 to 4.csv. Now I have these files. All right. Now, if I exit now, if I check the content of my DB files, I should see those files. You can see the files. Now, if I go into my DB files, I'm inside here, right? Let me touch some files. Touch from VM 1 to 3.txt. Now I created additional files from VM1, from VM2, from VM3. Now, if I do a Docker exec, let's check Docker exec into the container. If I check now, I should see those files. So data persistency allows you to write files back and forth. All right? Back and forth. Now, if I delete this container, Docker rm-f sendcon deleted. Let's check. Do I still have it? No. Do I still have my data? Let's check. Yes. My data is persisted. CO is persisted. Now, if I need to retrieve this data back into the container, I'm going to persist this guy again. I'm going to map this guy again to that location. So I'll recall my Docker run. If I hit enter, now if I do a Docker exec, I check my location, I will have those data. This is one easier way to move data from your host machine into the container. Is there any question, guys, before we move ahead? This was binding volume. All right. Now, normal volume. Copy, paste. A normal volume is a volume type whereby you create a volume whereby a volume is created using the Docker volume create command. Docker volume creates command and is mapped, and the created volume is mapped, right? Is mapped to a data directory within a container. So normal volume are volume that are created using what? Docker volume creates. Let's check. Exit. So I'm going to be deleting that container. So I will use deleted. There's a command called Docker volume ls. So Docker volume ls is going to list the volumes that I have in my Docker environment. You can see my binding volume is coming here. I don't know. It's not supposed to come here. I don't know why it's coming here. So these guys you're seeing, they are volumes as well, but they are called anonymous volume. We shall come to anonymous volume. Anonymous volumes are volumes without names. They don't have name. That's why they are called what? Anonymous volume. Now let's see other commands that we can pass to volume. Docker volume. So you can actually create a volume. You can list a volume. You can definitely run a volume. If you have like all these guys now, they are volumes without a name. So you can delete everything. So if I do Docker volume prone, it's saying that, do you want to delete everything? I say yes. They're all deleted. Let's check. Docker volume list. I've ended up deleting my this thing now. Oh, I didn't delete my directory. So I've deleted. I don't know why the volume is there. Let's check. I don't not delete my directory. Okay, my file is there. All right. So Docker volume. It removes all unused volumes. RM, remove one or more volumes. Then create, you can create. Inspect, you can always view the content of a volume. LS, to list the volume. So let's create a volume. So I'll say what? Docker volume create the volume name. Let me say data vol. This volume has been created. So if I say Docker volume list, I should have what? A data vol. Now I need to map this volume. But before I need to map this volume, let me check the content of that volume. All right. Let's see where this volume is located. Let's look at where this volume is located. To trace this volume, I will say Docker info. I'm going to look at the root directory of Docker. That's the home directory. The home directory of Docker, because Docker is a user. Yes, Docker is a container runtime, and Docker also creates a user. Once it also creates a user and a group. So Docker info is going to show you a lot of information about Docker. Look at. So Docker info, it says that client context is default, blah, 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 blah. Server container, you have currently 3 containers running. You have 3 containers, but 0 are running. 0 are paused and 3 are stopped. So if I say Docker ps-a, you can see that I actually have 3 containers. All right. So it shows you information about Docker. Now, how many images do I have? I have 17 images. Let's check. Docker images. Images. Let's count. I'll now say what? Word count -L. I have 12, but it's showing me 17. 14, 15. I don't know why it's 17, but that's okay. Server, backing, blah, 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 blah. Volume, local, network, blah, 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 blah. There's something we are looking for. The Docker home. So I'll say what? Docker info. Grep -root. So this is the Docker root directory. var lib docker. I don't know why I didn't see here. Okay, now this var lib docker. So in a situation where this output is too much, you won't be able to see this guy. So it's always better you filter it with your grep. So Docker info, I pipe it. I say grep root. So my Docker home is on var lib docker. So I'm going to change directory into this location and see what's inside of this location. I'll say cd var lib docker. Permission denied. I'll say sudo. I'm inside. Whoa. What's this now? Sudo -i. Let's change that. var lib docker. Now, when I list the content of this directory, pwd, all right, I could see volumes, trust, TMP, swamp, runtime, plugins, overlay, network, images, containers. Let's check what's inside of containers. So if I check containers, these are the containers I hash. These are the container hash. I have 3 containers running. Now let's check what's inside of images. Overlay. Image DB. Image DB. Content. SHA. So how many do I have here? Let's count it. Word count -L. I have 18 images. So I'm telling me that I have 18 images. All right. Let me come back. Now I'm concerned about volumes. Let's go to volumes. You can see the volume now. The volume is here. Data vol. Now let's check if there's anything inside of that data vol. It's just underscore data. Let's check underscore data. Underscore data inside of the normal volume is empty. There's nothing there. All right. So there's nothing there. So great. So let's now go back to our system. Let's now create a new container. I'll say docker run -d -name -con -v. I'm mapping the created volume, data vol, this normal volume to /app. Then the image name is sent img. Enter. Docker ps. Now let's do a docker exec. Docker exec -it -con bash. It's empty, right? Let's touch some files. Touch normal files 1 to 4.txt. Let's check. We've created these files inside of the container. Let's exit. Now let's check the content of normal volume. Let's check what's inside. So I'm going to say sudo ls-l var lib docker volume, is it capital V? Okay, I can't list this guy. Volumes now. Oh, I can't list. It's only root sudo -i. All right, let's go. So I'll change directory var lib docker, change into volumes. We have the data vol, right? Let's check if something has been written. Change to data vol. We have underscore data. Change to what? Underscore data. Let's check. Is there anything inside? Yes, there are things inside. So you can see our data is now persisted. Our data from our container is persisted. So this is with what? A normal volume. All right. This is with what? A normal volume. I hope it's understood. Now, the last but not the least is a anonymous volume. An anonymous volume is a volume type without a name. Without a name. All right. So how is it created? An anonymous volume is created without specifying any mapping directory. Any mapping directory or folder. So if you don't specify, if you use the what, the -v flag, and you don't specify what's it called? You don't specify a mapping volume. You only specify the one coming from the container. It will create an anonymous volume for you. So let me exit. Let me show us now. Let's say Docker volume list. So far we have just what? One anonymous volume. So let me delete this volume. So I'll say Docker volume remove. I'll paste this guy. Copy and paste. What's saying? Error from daemon. Remove this. Volume is in use. It's in use. Volume is in use. Let's forcefully remove it. -F. It's not going. Docker PS. Which container is using this thing? -A. Maybe one of these containers is using this volume. Bam. What do I do now? What do I do? Okay. But just take note, Sha. We have this number of volume. Just only one, right? So I want to create another one. So this is what I'll do. I'll say Docker run -d. The name is sent. Just sent. Then I'm using a volume flag -v space /app. All right. I could just say column. Let me see if it will fly. Then the image name, sent img. Docker PS created. Now let's check if this guy has created a volume. So Docker what? Docker volume list. So you can see it has created an anonymous volume. I didn't specify any name. Now let's use another method. Let me remove this column. Let me put S here. It has created an, again. Let's check Docker volume list. So it's either you put the dots or you omit the dots. It's going to create what? An anonymous volume. It's going to create an anonymous volume. So this is it, guys. So we've seen the three different types of what? Volumes. We saw the binding volume, we saw the normal volume, and we've seen what? The anonymous what? Volume. So we are going to wrap this session up with creating MySQL database. All right. I'm going to create MySQL database. I'm also going to create MongoDB database.
Just a quick question, please.
Yeah, man.
Yeah, what are the use cases for each of these ones?
It's for data to persist your data.
No, I mean, in what scenario, like use case, like when is one has an advantage over the other one?
Oh, these types of volumes. These types of volumes.
Yes.
Is that what you mean?
Yeah.
It's it all depends. It all depends what you want to achieve. All right. But we don't use anonymous volume because it doesn't have a name, so you can't identify it. So you have to avoid anonymous volume at all costs. You can always use either your binding volume or the normal volume. Okay.
Okay. All right.
Thank you. Now, thank you. Now, let's now do something very real. All right. So Docker images. Let me create a MySQL container and I will persist the data. So this is what I will do. I would say Docker run -d, right? Dash name is my con, right? My con. Then environment variable, must create environment variable. But let's create the error first. Dash P, MySQL runs on 3306. Then the image name is my SQL, right? So your image is not locally present, so it's going to download it and use it to create this container. Let's wait. So now the container has been created. So let's check Docker PS. It's not there. Let's check. It's exiting. Yes, the MySQL. So let's check why it's exiting. So I'll say what Docker logs container name mycon. So it's saying that I have not defined either of these environment variable. So these guys are very compulsory for the container to run. So I'm going to delete that container, mycon, deleted. I'm going to recreate it. But this time around, I'm going to add what? Environment variable. I'll say -e my SQL _root password is equal to 1234 double quotes. So if I need to set the user, I could say E again, column, sorry, double quotes, my SQL _database _user is equal to Toby. All right. So let's created Docker PS. Let's see if it works. So now it's running, right? It's running. Now let's do a Docker exec into the MySQL. So I'll say Docker exec -it container name mycon, then bash. So I'm inside of what? My container. Now let's print my environment variable. There's a command called print env. Print env is going to print all the environment variable in your environment. So now look at now. The host name is this. This guy, my SQL _root password, that's the value. My SQL database user, that's the value. All right. So these are your what? Environment variable. If I exit, if I do the same thing on my local machine, print env, it's going to print for me a lot of environment variables. We also have what? Present working directory. All right. So let's go back to my container. So I'm back to my container. Now let's log in. MySQL -u is what? Toby. The password. Oh, I didn't set the password 1234. It won't work. It won't work. That's for root. MySQL database user pass. Let me check. Let's check now. Let's check the official document of MySQL. So come here, Docker, and you say what? MySQL. Enter. Go to the official. So let's look at the different environment variables we could actually use. All right. So let's scroll down. Let me search for env. So I can use my SQL _root password. Okay, this is for the root password. Let's check environment variables. So you can create database. Okay, MySQL _user. All right. So MySQL _user goes with MySQL password. So let's go back there, guys. So let me exit. So this is what I will do. I'm going to kill that container. I'll say Docker rm -f. I'll say what? mycon. Now I'm going to recreate that container with the appropriate environment variable. So it has to be my user, not my database user. So it has to be my SQL _ user instead is Toby. Then the password for that user will be MySQL _ password. So meaning that I cannot log in with root password, right? So great. So this has been created. So let's exec now. So if I do a Docker exec, what is it saying? is not running. Docker logs my con. What happened? Okay, I have to set the root password. Okay. All right. So it's very mandatory, or I can keep it empty, right? So let's set the root password. So let's delete that guy again. Let's delete it. Now let's rerun it. So I need to set one last environment variable -e. So I'll say my SQL underscore root underscore password is equal to 1234. All right. So great. So let's do a Docker exec. Docker exec now, we should go in. So we are in now, right? So if I print env, print my env, I should have my user password, which is Toby, my root password, and my user is Toby. So I'll now say what? MySQL -u is Toby, then the password is 1234. So I can log in with what? The Toby user. You can see. So that Toby user, I've logged in with the Toby user. If I exit, I can equally log in with the root user. I can say root. Root password is 1234. I am inside as well. All right. So using that Toby user, all right, we can do a lot. Let's use that Toby user 1234. So let's show databases. Let's create database. Let's see if the Toby user can create database. Create database TobyDB. Toby doesn't have the right to create database, not unless this right is granted towards to Toby. All right. So I wouldn't want to digress, because if I digress now, it's we are going off the radar. Okay. To grant permission, all right, role permission for the Toby user. Okay. But it's something that you can always look it up. Can always look it up. Can always say how to grant create DB access in MySQL. Create the database permission in MySQL. All right. So I have to create MySQL user and grant database creation privilege to a user. Privilege to a user. So just to grant all on these at Toby at localhost. How can I say error? How can I provide access for the admin? Well, let's see. Grant all privileges, everything. Login as admin without password. All right. Show grants. All right. So let's see. I don't want to grant everything. I can always flush. Though this is not DB class though. Let's see now. Let's just grant everything. Just to show us something. All right. So I'm going to log in with the root user. Here's the root 1234. So I'm going to say grants. Grants what? Grants all privileges on everything. All right. To be, all right, at local host. You are not allowed to create a user with grants. Yeah, you're not allowed to create a user. Wait. Wait, let's see this error. Copy. This means that to grant some privilege to a user, the user must be created first. We've created the user. Let me check this. MySQL documentation. Create user this, identified by change me, password expire. Okay. Show grants. Show privileges. There are lots. Okay, grants creates. Grant creates. Okay. Grant creates on this guy to this guy. Let's see. Grants creates. I don't like the digressing. Grants creates on 2b dot asterisk. This is stable. This is stable. It's stable. It's stable. All right, guys, let's not digress. Grants for user. Let's not digress. Grant developer user to. These are rules. Let's not digress. All right. So let's come back. Let's come back. Now, who is this? This is root. So show databases. Okay. Basis. Right. So let's create database students info. Right. So show data basis. So student info database has been created. So let's exit. All right. Let's exit. Now, each time you create, you create a MySQL container. MySQL container automatically creates an anonymous volume. Let's check. So if I say Docker volume ls, I no longer know which is which now. All right. But either of these guys is an anonymous. Okay, let me try to prone it now. Docker volume prone. Yes. Then we should be left with, okay, either this. All right. This AB should be that. AB should be that. So if I do go here and I go to change directory var lib docker volumes, then anonymous volume. This should be this guy. Copy this guy. Copy paste. Then underscore data. And let's check. It's empty. It's empty pwd. Change directory into, let's look for 08. Change directory underscore data. Let's check. All right. So that's 08. So this is my SQL data that have been persisted into what? Anonymous volume. You can see. Can you see that database that we created? Student info is here. So whenever you create MySQL DB, it automatically creates for you an anonymous database. So let me exit. So let's now see how we can persist MySQL DB, right? MySQL data. So let me delete this guy. Is gone. All right. Now let's empty everything under my DB files. All right, let's check my DB files. We have all of these. So I'm going to empty everything here now. So I'll say this guy, asterisk. So it's now empty, right? So I'm going to what? I'm going to create now a persistent, a binding volume with my MySQL container. So I'll call that, recall that command. So here it is. So somewhere here, I will say -v, $pwd / my what? DB files, right? Column / now MySQL has a root directory where all those files, you can find those files, which is MySQL home. So let's check the official documents. All right, let's check the official documents. That should be, this is the official document. Let's check for the root directory of MySQL. So I can search, if I go to volume, let's look for volume. Let me find Control F, volume. So you can see MySQL stores all of its data under /var/lib/MySQL. So that's where MySQL stores all of its data. So if you want to do a mapping, so if you want to persist any data coming from MySQL, you have to map this location to anything outside of here. So let's go there. So I'm going to map this guy towards /var/lib/MySQL. All right. So I'll hit enter. The moment I hit enter, now let's check the content of my DB files. My DB files already have everything. You can see it already has everything. Okay. So now I'm going to exec into that container. Docker exec. I'm inside. So I want to say MySQL -u root, then password 1234. I'm inside. So I'll create a database. Create database. I'll call it customer _ details. Now show databases. I have what? Customer details. Now if I exit, if I check the content of my binding volume, I should see what? Customer details. So you can see everything I'm doing is persisting. Likewise, if I go into this guy and I create a file, let's say touch finance.txt, all right, LRT. So I've created this file called finance from my host machine. So now let's do a Docker exec into the container. So if I do a Docker exec into the container, then I go into var lib MySQL. Under this location, I should see LRT, ls-lrt, finance. All right. So with all of these in place, we have successfully, all right, talked about Docker volumes, right? We've seen how to persist database data, container data, all right, to make it stay alive, that data will not get lost. So we're still going to see data persistency again when we get into Kubernetes. So at Kubernetes, we shall set up data persistency with AWS, EFS, or EBS. All right. So we'll see how persisting your Kubernetes data works at that level. This is just to give you an insight of what data persistency is. All right. So that being said, I want to bring this session to a close. But before then, is there any question before we draw the curtain close? Is there any question? So I'll be dropping an assignment. All right. This assignment is for MongoDB. So you're going to create a MongoDB container and persist the data. So you have to find out which, where, you're going to find out the path inside of MongoDB that stores all of its important files. You know how I did mine? I went to what? I went to Google and I said, Docker MySQL, right? So once you open the official link, you search for volume, you will see the path, right? I've just even given you the expo. I'm not even saying it. All right. So guys, that is it. I'll drop the assignments. So okay. All right. So let me end this session so that I don't elongate things. Stop recording.